All right, carrying on from our right angle or non-right angle triangle trigonometry that we just spoke about earlier. So earlier in the Zoom class, we spoke about getting the area of a triangle using the formula half AB sine C. So the sine rule is, so when we have non-right angle triangles, so oblique triangles, so remember that we name the angles with capital letters. So we have A, B, and C for our angles. The sides are directly, so the letters, the same letters are going to be directly across from each other. So A is opposite the angle A, but the sides will be named with small letters as opposed to capital letters. All right, so that's what we have to remember in oblique triangles. The sine rule is a way of finding missing pieces of information about a non-right angle triangle. So in other words, finding a missing angle or finding a missing side. Now the key to using the sine rule is you must have a side and an opposite angle to be able to use it. All right, so you must have those two pieces of information to be able, at least those two pieces. So you must have one full containment in order to be able to find a missing piece of information. So let's look at an example of where this would be, that we'd be able to use this. So if we look at this, this is a question from page 187. And it's question 1 part B. So looking at the triangle that I have here, we have an oblique triangle. We have an angle of 60 degrees here. We have 8 centimeters. We have 7 centimeters, and we are missing angle A here. So in order to check, can we use the sine rule? We must have a side and an opposite angle. In this case, so you need to be able to draw a line from the side to the angle and have both pieces of information. In this case, we do. So therefore, we can use that ratio to find our missing angle. So the formula for the sine rule is A over sine A equals B over sine B equals C over sine C. In other words, all the sides and angles are in proportion to each other. Now, we can either use this version of the formula when we are looking for a missing side, because obviously we want the piece of information that we are missing to be on the top of a fraction line. Or else, what we can do is we can flip the formula to say sine A over A equals sine B over B equals sine C over side C. It doesn't, both formulas are the exact same, it's just one is a rotated version of the other, so they will give us the exact same piece of information. In this question, in question 1 part B, we are looking for a missing angle, so therefore I'd probably look at using the sine of the angle on the top of the fraction and the side on the bottom. So to set it up, we only need 2 fractions. We don't need to look at all 3. We're not looking for the third piece of information in the triangle at all. So filling it in, we're looking at the missing angle being angle A, so sine of A over the side A. So remember, in a non-right angle triangle, the side A is directly across from the angle A, so that's going to be over 7, is equal to, and this is where our piece of information that we have comes into play. So we're looking at sine 60 over 8. All we need to do then is isolate the missing variable. So in this case, the missing variable is A. So we multiply across by 7. Sine A is 7 times by the sine of 60 over 8. And because we're looking for the angle, remember, to get the angle when we are given the sine, A is the inverse sine of 7 sine 60 over 8. Now, you can type it into the calculator as you go, just the danger is that you lose accuracy as you go along. The best thing to do is make sure that you type it into the calculator as one go right here at the very end. And in this case, our angle A, so if we're looking at the inverse sine of 7 sine 60 over 8, that gives us an angle of 49.26, so 0.3 degrees, correct to 1 decimal place. Just check what, yeah, so we want to give all answers correct to 1 decimal place. So that's where we're looking at a missing angle, all right? So again, we're using our formula, A over sine A or else sine A over A. fill in the missing piece of information, and solve. If we're looking at a missing side, so looking at question 1 part A, in this diagram here, we have an angle of 70 degrees, we have an angle of 30 degrees, we have 4 centimeters, and we have X. Again, we check, can we draw a line from an angle directly across to a side, and we have both those pieces of information? We can, so therefore we can use the sine rule. If we can't do that, so for example, if I had, I'll look at a different example later on. So we know that this is 4 centimeters. All right. So we know that 30 and 4 are directly opposite each other. Now in this case, because we're looking for a missing side, I'm going to use the top version of my formula. So X over the sine of 70, remember it's opposite, over the opposite angle, is equal to 4 over the sine of 30. Again, we're looking to isolate the X. All we do is multiply across by the sine of 70. So X is 4 times by the sine of 70 over the sine of 30, which gives us, so 4 sine 70 over sine 30 gives us X equals 7.5 centimeters. All right, so those are 2 examples of where we can definitely use the sine rule. Let's look at this triangle now for a second. So remember, we can use the sine rule if we have an angle and a side directly opposite each other. Say, for example, I had 7 centimeters here, 8 centimeters here, and 68 degrees here. In this triangle, I cannot use the sine rule. I do not have sufficient information to be able to draw a line, so we don't have that pair. We do not have that pair, and therefore we can't use the sine rule. You have to have a side and an angle directly opposite in order to be able to use the sine rule. This is, we can actually use this triangle to find the area of the triangle, and there's another rule called the cosine rule, which we'll discuss in another video later on. But that's how we tell which rule we're going to be able to use. So what I would like you to do is attempt a few questions on pages 188 and 189. Right, so watch this video. I'll put the questions into Google Classroom as an assignment, and I will correct them then on Thursday. Thank you.